Professor Bright here, and we are going to continue talking about writing in mathematics and continuing to explore some of the stylistic aspects of writing in mathematics. Okay, so previous videos we've discussed such things as make sure that our punctuation's correct, make sure that we don't start an equation with mathematics, and also worrying about paragraphing and conciseness. Okay, this video we're going to dive a little bit further into some more particular aspects of mathematics. The first of which is for us to use when we're ever having to work with theorems or properties. And here, in those instances, we need to make sure to verify all assumptions and hypotheses. Now, this may be a trivial thing, it may be a complicated thing, depending on the theorem that we want to use. Okay. Also, just as a general note, this actually extends to, this is a good tip for all homework and exams too. Okay. I know in previous exams that I've graded, there's always been points allotted to making sure that the assumptions or hypotheses are verified. And I use the terms hypotheses and assumptions kind of interchangeably here. Technically, when you're talking about a theorem, it's a hypothesis, and a property, it's still a hypothesis, an assumption. So just know that I personally use the terms interchangeably. Formally, though, hypotheses is the generally accepted term. Okay, and so I have a theorem here which was introduced to you this week in class when you were talking about continuity, and it was the intermediate value theorem. So this is not the exact wording that was presented to you in class or as in the textbook, but it's an equivalent version. So it says, if a continuous function f on a certain domain AB has values f of a and f of b at each end of the interval, okay, then it also takes on any value in between f of a and b in that interval. Okay, so just as a example here, let's consider a nice polynomial function. Let's say f is 3x squared plus 2x minus 5. Okay, and let's say we're on the interval, I don't know, let's say -1 to 3, and we'll be on the closed interval. Okay, so if my professional problem requires the use of the intermediate value theorem, or IVT, I need to make sure that I satisfy all the hypotheses. Now, you'll also notice that the way I have it presented here, I have it in two colors. There's a red part and a blue part. Okay, the goal, or what I want to get out of the intermediate value theorem, is the blue part. That's what I want to use it for. Okay, but in order to use it, I need to make sure to satisfy the hypotheses, which is the red part. Okay, so hypotheses is this red part, and so I need to verify a few different things, right? If I read the red part carefully, it says if a continuous function, okay, so first thing I need to satisfy is if it is continuous, and this is my abbreviation for continuous. Okay, and then it says on domain. Okay, so I need to check the domain. Okay, domain. And this is just me thinking in the background. This is not part of the formal writing yet. Has values f of a and f of b at each end of the interval. Okay, so I need to find f of a and f of b. Okay, and then that's the end of the red part. Okay, so in order for me to use the intermediate value theorem, I need to satisfy these three pieces. Okay, and your writing needs these three pieces. Okay, so you need to justify, okay, why it is continuous, why it has that domain, why, and then you need to find the values f of a and f of b. Okay, so just as an example, now, okay, I've maybe done some background work, and if you need to pause and think about this a little bit more, please pause the video and think about, why is it continuous? Why is it, or does it have the domain property that we need? Does it have the f of a and f of b property that I need? Okay, but I'm going to press on and I'm going to say, okay, well, So this is me writing now. So since f is a polynomial function, it is continuous. Okay, so I verified condition 1, and I'm going to continue to verify the other conditions. Further, oops, let's go back here. So further, f is on -1, 3, and f of -1 equals, and I'm not going to do the value of the computation here, but and f of 3 equals blank. So the intermediate value theorem, and I'm going to actually write it out, no abbreviations. Intermediate value theorem may be applied. Okay. So that's just an example of taking a theorem, verifying the assumptions or hypotheses, and then later on, by the, and then I'm going to write out IVT just as abbreviation right now because I don't want to take the time to write it out. We obtain, and then this part would be where the conclusion of a conclusion, if I can spell that correctly, would be stated. Okay, so that is an example of how you would use a theorem in formal mathematics, mathematics writing that is. Okay. The next thing I want to mention is that any graphs or figures that you include need to be numbered, centered, captioned, and explained. Okay, so I know this week in your professional problem, it's typically the infamous Monk problem, and it is one of my most favorite professional problems that you're going to see in Calc 1. And the intermediate value theorem is going to be used in some creative way. And in the past, some students have wanted to include graphs or figures in this problem. I personally, if I was writing it, I probably wouldn't, but hey, it's a style thing. But let's say I wanted to include a graph of this function that I have up here that we did with the IVT. Okay, so what I would do is I would have writing, and then period. Oops. And then I would say, okay, here is my graph. Okay, it's a nice parabola. I'm not going to take the time to include what it exactly looks like. Okay, but make sure you have y and x and all that stuff, and you label it. And then I would say graph 1, graph of f. Okay, and that, oops, that would be an example of, and then maybe there's some additional writing here, but then that would be an example of the graph being numbered. Okay, so I got a number. I have it centered, well, relatively speaking, and caption. Okay, so caption is just a brief description of what is being shown in the graph. Okay, this also goes with, so you can do the same thing with graphs, tables, okay, charts. Some people make a distinction between graphs and charts. It's sometimes needed. Okay, and then later on I would say as shown in graph 1, f opens up. Okay, something like that. And I would continue to explain. Okay. So again, just to recap what we've said so far, when we're using theorems or any properties, verify all assumptions. Okay. Graphs and figures need to be numbered, centered, captioned, and explained. Okay. And the last thing we're going to talk about in this video is it's completely optional. Some people like doing this, you don't need to, but you could index equations with numbers. So for example, let's say I have 3x squared, so my function, and I wanted to find its vertical intercept, so I might set it equal to 0, and I might say off to the side I might do a parentheses with a 1. Okay? And that can be useful later on, because then in your writing what you would do is you would refer to this as equation 1. Okay, and reference, so like as seen in equation 1, da 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 da. But this is a style thing again. I personally don't use this in my writing. A lot of students like to do it because it helps them organize their thoughts and clearly reference, and it helps with that accuracy and conciseness component too. Okay, so that's going to be the end of this video, and in the next video we'll just go through an example where we're going to do an example with the IVT that kind of illustrates all these different components.